Remember when you open your old diaries or your childhood photos, a montage of memories just starts to flow through your mind. It's time travel back to those moments and live those moments again. See how fascinating that is. You see from where you have come. That's the feeling an astronaut gets when he sees the outer universe. He sees from where he has come. The universe is our past. It tells us our existence. This fascinates us, this fascinates me, and this is the fascination that makes us discover the outer universe. As NASA is doing different missions to examine extraterrestrial bodies, and this thirst of knowing ourselves led NASA the mission of closely examining an asteroid discovered in 11th of September 1999, and it was later named Bennu. It was named by a 9-year-old student after a name of a bird. It's 500 meters in diameter, a little more than Empire State Building. Now the question arises, why Bennu? What's so special about it? Why are we digging soil out of this asteroid? It has some solid reasons. First reason is that it is almost spherical in nature, which makes it easier for the spacecraft to examine. Second reason is that this asteroid is very close to Earth and its orbit is somewhat similar to that of Earth. Next thing is that it is very old and carbonaceous. By term carbonaceous, we mean that it has a large number of carbon compounds. And as we know, that carbon compounds are mainly organic compounds. So in this way, we can find the answer of our lifelong question that from where life came on Earth. And as life depends on these organic compounds, this asteroid Bennu may be the answer of this question. Next reason is that Bennu can give us a lot of history of our solar system, how the planets were formed and from where the water came and things like that. There are many further unanswered questions which may get answered after the examination of this asteroid. Here I want to add that this asteroid is considered to be on a collision course with Earth. This is because it has relatively higher chances of collision, about 1 in 2700. For that purpose, the NASA launched the program OSIRIS-REx. In this program, a spacecraft is launched into the space for a sample return mission from Bennu. It was launched in 2016, and next year in 2017 it flew by Earth again. It used the gravitational field of the Earth to incline itself with the orbit of Bennu, because we can see that the orbit of Bennu is slightly inclined with respect of Earth. So the orbit of the spacecraft also needs a little bit inclination, which it will get from the Earth's gravitational field. Finally, it caught the sight of Bennu in August 2018, and it is estimated that this spacecraft will reach the Bennu on 3rd December 2018, which is, by the way, my birthday. This spacecraft will deeply scan the Bennu to find its exact shape and surface area and size. Now I will like to talk about Jarovsky effect. It is necessary to calculate Jarovsky effect to estimate the trajectory of a particular comet, asteroid, or any extraterrestrial body. This Jarovsky effect is best explained by Mr. Bashar Rizk.
Any object in the solar system experiences the Jarovsky effect. Now, what is it? Well, it's a thermal asymmetry that happens because of the rotation of an object.
As the sun's energy strikes Bennu, it gradually changes the asteroid's orbit.
Things have had a chance to heat up. Now, when something is hot, it tends to emit photons, thermal ones. Photons carry momentum. So what this is doing is acting like a little bit of a thrust in this direction. If I thrust that way, I'm kind of increasing the energy of the orbit and moving it out from the sun a little bit.
As I have already told that it is said that this asteroid is already on a collision course with Earth, so finding this Jarovsky effect will be very helpful in finding that this hypothesis is right or wrong. Now I will talk about this spacecraft itself and its mission. This spacecraft, OSIRIS-REx, is an example of its own. It's full of innovation. It will use the groundbreaking DAG-SEM technology to extract the soil of the Bennu, which means that it will not actually physically land on Bennu, but instead it will just hover above the surface and will extend its mechanical arm to the asteroid. This arm will extract our sample within 5 seconds. This means that the spacecraft will be in contact with the asteroid just for 5 seconds. After that, this extraction will be placed in a properly sealed capsule, and this spacecraft will come back and launch this capsule in the gravitational field of Earth. It is estimated that this capsule will reach Earth's ground in 2023 in the Utah desert. This sample will help for decades in upcoming scientific era. And from here, I finalize my presentation about Bennu and the OSIRIS-REx program. Thank you.